Good morning students, myself Dr. Bharatraju LB, Associate Professor from Mechanical Department, Shashi Institute. So today we are going to discuss about engine and types of engines, working principle of a 4-stroke engine and working principle of a 2-stroke engine, and later on Otto cycle and diesel cycle. So coming to the point, here engine is a power source to any kind of automobile, right? So here if we talk about engine, so in engine we have internal combustion engine and external combustion engine. So here by the name we can see internal combustion engine means the combustion is taking places inside the cylinder. That is why it is called as internal combustion engine. Example, nowadays what we are seeing like 2-wheelers, 4-wheelers, cars, buses, lorry and etc. Right? So here EC, external combustion engine, means earlier we have steam engines. With the help of steam we are driving the road wheels. So that will comes under this external combustion engines. And how we are going to classify engines? So when we want to discuss about types of engine, that is classifications of engine, we have different points. For suppose if we are talking about type of fuel used to run the engine, we have petrol, even kerosene, diesel, petrol, LPG, CNG and etc. All these comes under types of fuels which we are using to burn the fuel, right? And coming to the point, cycle of operation. Here we have Otto cycle, diesel cycle, and dual cycle. All these comes under air standard cycles. Next we have, depending upon the speed also we can classify IC engine, that is slow speed, medium speed and high speed. So here less than 400 RPM means slow speed. So here 400 to 1000 RPM means medium speed, and if it is greater than 1000 RPM, then that will comes under high speed engine. And based on the cooling system, so engine generates heat, we need to extract some of the heat to run the engine continuously. Coming to this cooling system, we have water cooling. Coming to this cooling system, we have water cooling. Engine is cooled by circulating the water throughout the cylinder, that is called water cooling. And here we have air cooling. Take an example of a 2-wheeler which is a single cylinder air cooled engine. And next one is liquid cooling. All these different types of cooling systems comes under type of a cooling system employed in the engine, that is comes under types of engines. Next we will see working principle of a 4-stroke engine. So working principle of a 4-stroke engine, we will discuss about SI engine. SI means spark ignition engine. So here we are naming it as 4-stroke engine. So here we have 4 different strokes. So what is meant by stroke? If we see engine consists of major components, right? So this is TDC and this is BDC, right? So components means this is cylinder head and this is cylinder block and this is crankcase. So these are all the major components of an IC engine. So here we are discussing about 4-stroke engine, means 4 different strokes. So this is top dead center and this is bottom dead center. So what is meant by stroke means displacement of a piston between dead centers. So here we have top dead center and another one is bottom dead center. So in between these two dead centers only, piston will reciprocate inside the cylinder. Okay. this drawing we need to remember. On the cylinder head you can see three names. One is IV, inlet valve, SP, spark plug, and EV, exhaust valve. And this is a crankshaft, and this is a connecting rod. So here piston will reciprocate inside the cylinder, means this reciprocating of piston, here we have crankshaft, so this rotation of crankshaft will be converted into reciprocatory movement of a piston with the help of this connecting rod. So here crankshaft is rotating and piston is reciprocating inside the cylinder. It means conversion of rotary movement of crankshaft connecting rod to piston is, we are using connecting rod. This connecting rod helps to convert rotary movement of crankshaft into reciprocatory movement of piston. As we know, 4 strokes means first one is suction stroke, and second one is compression stroke, and third one is power stroke, and last one exhaust stroke. So in suction stroke what is happening? So piston will move downwards. So here when the piston moves downwards means its volume is getting increased, thereby through this inlet valve opening, the charge is getting inside the cylinder. So here what is meant by charge? In SI engine, charge means petrol plus air. So in SI engine, charge means petrol plus air. Okay, so that is admitting inside the cylinder through this inlet valve opening, right? So in the first stroke, piston moves downwards, that is piston is moving from top dead center to bottom dead center, thereby through this inlet valve opening the charge is getting inside the cylinder. So here what we need to remember, piston moves downwards, and second point, through inlet valve opening charge gets inside the cylinder, and third point, exhaust valve remains closed. Okay, so all these important points we need to remember. So this is done. Next one is compression stroke. So what is happening in compression stroke? In compression stroke, piston moves upward, and to that drawing, piston moves from BDC to TDC. Okay, here we can observe that when the piston is moving from bottom dead center to top dead center, its volume is getting increased. So to this charge, it increases pressure and temperature, right? When the volume reduces, obviously what we need to remember, its pressure and temperature is getting rise. So thereby, what is the important point we need to write? In compression stroke, first point, piston moves upward. Next, here charge gets compressed. Next, both the valves remains closed. Okay, so here 3 important points we need to remember. One is piston is moving upward, volume is getting reduced, pressure and temperature of compressed, charge is increased, and both valves remains closed. So these are the important points we need to remember. So next one is power stroke. What is happening in power stroke? So at the end of compression stroke, what we need to understand? Already charge gets compressed, due to which pressure and temperature increases, right? And at the end of compression stroke, spark plug ignites. Charge means combustion occurs. So inside the piston cylinder, combustion occurs. Due to that explosions, that pressure pushes the piston downwards, right? So for that you need to draw this kind of diagram. Okay, we need to show both valves remains closed, spark plug ignites the charge, thereby combustion occurs, that forces the piston to push downward. So this line indicates piston is moving downwards due to the combustion occurs inside the cylinder, right? So to this, here due to the combustion of charge, piston moves downwards, right? Next, how that combustion occurs? Spark plug ignites the charge, and next important point, both valves remains closed. So here IV and EV remains closed. Okay, this is regarding power stroke. And now we will see what is happening in exhaust stroke. In exhaust stroke, what we need to remember is, so piston moves upward, right? Here what we need to remember, this exhaust valve opens due to the piston movement and the burned gases will leave the cylinder. That means cleaning the cylinder is happening in exhaust stroke. Okay, so for that you need to remember this dying. An important point is, through exhaust valve opening, the burned gases will leave the cylinder, right? And inlet valve remains closed. Okay, and third point, cleaning is happen inside the cylinder. And finally, we have a small note here. In 4-stroke engine, to complete one cycle of operation, for suppose for half cycle, it will complete one stroke. Let us take an example. This is suction stroke, right, up to here. Another one is compression stroke. This one is compression stroke. So here 180, one more 180, that is 360 degrees. So here two different strokes were already completed. And next one is power stroke. This is power stroke. We can also call it as expansion stroke or working stroke. Three different names we have here. Okay, and finally this is exhaust stroke. So this is 180 degrees, this is another 180 degrees, and one more 180 degrees, and as well as last stroke also occupies 180 degrees. So here, to complete one cycle of operation, the crank has to rotate 720 degrees. So what is the purpose of drawing this diagram is, we need to understand, to complete one cycle of operation, 4-stroke engine requires 720 degree of crank rotation. What is the crank rotation? This one. So this is crank shaft. So to complete one cycle of operation, the crankshaft has to rotate 720 degree of crank rotation. Thank you one and all.